One of the common questions that's been hitting my email in the past few hours has been percent dissociation. It's related to one of the homework questions. Percent dissociation is not percent composition or mass percent or solution percentage. Right? Percent dissociation is how much a reaction falls apart. Usually we're talking about a reaction where one component decomposes into several other things. This is very common in acid-base chemistry, where you have a weak acid and it falls apart into H plus and A minus. That's not how it happens, really. You know, we know that this is Bronsted acid-base water proton transfer. But we can simplify this and talk about percent decomposition. And they'll talk about how it's 30% dissociated. What that means is that 30% of this compound has fallen apart. Depending on stoichiometry, this might mean there are many more components than just the 30%. But what that means in reality is that they've given us information about the equilibrium at the end. And we talk about this ice table. So we set up our ice table and the equilibrium at the end, the question you have to ask, do I have information about the equilibrium? And the answer is yes. All right? They say that at the end, 30% will be gone, leaving us with 70%, leaving us with 70%. So if this was originally 1 molar, we would lose some, right? But they've just told us that it is now 70% its original amount. We now know how much is left. Right? And so it doesn't really matter what our starting condition is then. We know that at the end, there's 70% of it. So in this particular example, 1 molar minus X would equal 0.700 molar. If this had been half a molar, it would be 0.35 molar, 70%. So we now can solve for X, regardless of what X is. So it's just like being told that the molarity at the end of this reaction is 0.335, right? Or what have you. All right, so hopefully that helps.